So now I want to show you how to calculate the work to empty a tank that's a little bit more interesting. So we're going to look at a conical tank, and we're going to pump the water up out of the top. So I'm going to go ahead and draw one of my representative discs in there. And so remember the idea. So work is force times the distance. Force is mass times acceleration, and acceleration for us is gravity. The mass, we need to know the density. We'll pretend this is water again. So our density is 1,000. Right? And I'll get my units in there, kilograms per cubic meter. And then the work is how far we have to lift it, right? So I have to lift this disc here, right, farther than I have to lift a disc that's up here at the top, right? So it changes as we empty out our tank. So here we go. Volume of a layer. So the volume, so I have a circle, right? It's the area of the circle times the thickness. So the area, I'm just going to stay basic. So pi r squared, the thickness, right? That's our dy. Now you might notice on, a conical tank, the radius differs, right? It's not the same everywhere here. So I'm going to go ahead and pop in some axes. And I'm going to put the origin at the vertex of our cone. So the r value is actually, the same as the x value. So r is the same thing as the x value, right? So I have pi x squared dy, right? And right away you notice the trouble. I have an x squared, but I'm integrating with respect to y. So I need that relationship between x and y. So there are a couple ways you can do it. You could do some similar triangles. It's actually pretty easy to find the equation of that line. So I've labeled my cone to have a height of 2 and a radius of 1. Okay, so if you kind of look at the setup where I've drawn my axes, right, it goes through the origin and it goes through the point up here, 1, 2. So the equation of that line, so y equals the slope is 2, x, y-intercept is 0, so it's just y equals 2x. So if I solve this for x, that tells me that x is equal to the same thing as y over 2. So up here, my volume of my one layer is going to be pi times y over 2 squared dy. Okay, so then the mass of the layer. Mass of a layer is that volume times the density. So for us, that then will be pi times y squared over 4 times the density, 1,000. Remember my dy. I'm sure I've got everybody. Okay. The force. So now we're just going to bring in our force of gravity, 9.8 or 9.81. So I've got pi times 1,000. I'm going to go ahead and kind of move some things around. So this y squared, I'm going to go ahead and move over. So I've got the 1,000, got it over 4. Here comes gravity, 9.8. And then I have y squared dy. I'm getting to that place where I have that, all this stuff up here, that's just a constant. So I'm going to probably pull that out in front here in just a second. So now let's think about the work on that one layer that we've drawn. So the work is the force, so the force is right here, but it's force times the distance that we have to lift that layer. So this layer here has to go from where it is all the way up to the top, right? So this amount right here is y. The whole amount right to the top is 2. So the amount that this layer has to get lifted is 2 minus y. So it's going to be the force, which is k times y squared dy, times the distance, which is 2 minus y. And that looks totally ridiculous. So let's go ahead and put it in the order it's supposed to be. So we'll have that k out front, and then I'll take the y squared through the parentheses, so times 2y squared minus y cubed dy. Okay, you can check my algebra on that. And now we're going to add all of those up. And so, okay, look at the picture one more time. Where do our dy's go from and to? Where do they start? Right, so the very first one's down here at y equals 0, and they stop up here at y equals 2. So those are, right? The different places where you could have your layer of water being lifted out. So we're going to go ahead and integrate between 0 and 2. Again, because, right, it's a dy, and those are the y values that we have. I've got that k out front. We'll find its value in a second. 2y squared minus y cubed dy. So go ahead and use your power rule to find your antiderivative. So 2/3 y cubed minus y to the 4th over 4 between 0 and 2. So now we have k times 2/3 times 8 minus 16/4. 0, right, ends at 0, so minus a 0 there. So we're at k times 16/3 minus 16/4. I know, it's 4, I get it. If you do that math, common denominator if you want, I don't know why it was seeming like that was the right place to go. It turns out to be, right, 16/12 times k. So now we're in joules, so let's go ahead and figure out what k was. Where was all that stuff up there? Okay, so I've got 16/12 times pi times 250 times 9.8. Okay, so that's in joules. 16 divided by 12 times 250 times 9.8. So 3266.7 pi joules. Okay, so my folks who like the fraction, 9,800 third pi, if you wanted to know the exact value.